All right. Welcome everyone to the Algebra 2 6.5 notes interpreting polynomial graphs. We're going to talk about different kinds of polynomial graphs, how to identify some of their features, and we're going to talk about end behavior. So to begin, we have a series of graphs here, starting off with linear functions that we are going to sketch and talk about their degree, lead coefficient, and end behavior. So first, let's get a sketch of these graphs. So a linear function is just going to create a straight line. Each of these ones, y is equal to negative x and y is equal to x. We're going to remind ourselves that when there's no number in front of that x, that leading coefficient is a 1. So that leading coefficient on y is equal to negative x is negative 1, and the leading coefficient on y is equal to x is a positive 1. Let's see if we can sketch these guys out. So that negative 1 is also our slope. So on the left here, starting at the origin, I'm going to follow that down 1 and over 1. I'm going to quickly sketch out these graphs. Excellent. All right, I'm going to do the same thing with the positive one, going from the origin up 1 and over 1, sketch these graphs. Okay. Now, the degree here refers to the degree on the polynomial, which is the power. These don't appear to have powers, but it's simply a first power that we don't see. So the degree for a linear function is the first degree. First. Okay, end behavior. This is something new. This is talking about what the y's are doing as the x's progress to the left and right. So meaning as our x continues to the left, in other words, it is heading towards negative infinity, what exactly is the y doing? Well, you can tell that the y here appears to be increasing. It is increasing all the way up to positive infinity. And on the right, as the x's approach infinity, you can see the y's are doing the opposite. They're heading downwards towards negative infinity. This is called end behavior. Now, the way we're going to write this out is x, and then we're going to have an arrow, and then negative infinity. Now, what this actually reads as is as x approaches negative infinity. Then we're going to tack onto that what y is doing. Well, as we saw over here, as x approaches negative infinity, y is approaching positive infinity. Then on the right side, we have as x approaches positive infinity, what is y doing? Well, y is approaching, we can see it right here, y is approaching negative infinity. Okay, you can notice on our positive linear function that things are a little bit differently. So I'm going to pop in here as x approaches negative infinity. What is y doing? Well, we can tell on the left side of this graph that as x is going to negative infinity, now y is also going towards negative infinity. So we'll write down y is approaching negative infinity. And as x is approaching positive infinity, in other words, moving towards the right in the greater numbers, we can tell that y is also approaching positive infinity. So we'll write that in x arrow, infinity, y arrow, y is approaching positive infinity. Okay, then let's see how this changes when we talk about the quadratic function. So in the quadratic function, we have the square on the x. Of course, that's the second power, which tells us automatically that this is a second degree polynomial. The leading coefficient on each of these, again, there's no number that we can see in front of x. In other words, there's still that 1. So we have negative 1 and a positive 1 for our leading coefficient. So let's sketch these graphs out. I'll do the one on the right, the positive one first, starting at the origin, kind of head up 1 and 4 to the right and to the left, getting that beautiful curve. Lovely. And then the negative version on the left, essentially the same graph with a vertical reflection. Not bad. Okay, let's see if we can figure out the end behavior. So again, I'm going to write down as x is approaching negative infinity, in other words, as we move towards the lesser x's, and as x is approaching positive infinity, the greater numbers to the right, what is y doing in each case? Well, as we can see, as we head towards the negative numbers here, do that here, pink here, easy to see, as we move towards the negative numbers further to the left, y is heading downwards towards negative infinity. So let's pop that in. Y is approaching negative infinity. And on the right side, as we approach more positive x's, you can see y, because this is a parabola, is also heading down to negative infinity. There we go. Okay, and you can see that things are just a little bit reversed on our positive one over here. So as x is approaching negative infinity and as x is approaching positive infinity, we can see y approaching this time. In both cases, as you can see the arrows going upwards on this one, we can see in both cases it's heading towards positive infinity. Not my best infinity sign there. All right, now let's talk about two shapes we're a little less familiar with, the cubic and the quartic. So on the left here, the cubic has an exponent of 3, meaning it is third degree. Okay, so what do these graphs look like? I'm just going to put a simple sketch in here. So for the positive one, it's just going to come down from below, curve in at the origin, and then curve back up again. Okay, and on the left, when it has that negative leading coefficient, it's going to be reflected vertically. Not bad. Okay, so the leading coefficient again is -1 and 1. And the end behavior. So as x approaches negative infinity and as x approaches positive infinity, what is this graph doing? Well, as we head off to the left towards negative infinity on the x-axis, you can see the y's are heading upwards towards positive infinity. So y is approaching infinity. And on the right side, as the x's are increasing towards infinity, you can see y decreasing towards negative infinity. Very good. A little bit different when the graph is not reflected, but again, let's start with x is approaching negative infinity and x is approaching positive infinity. Okay, this time, as we head to the left towards negative infinity on the x-axis, we can see y is decreasing in this direction. So we'll pop that in, that y is approaching negative infinity. And to the right, as the x's are increasing towards infinity, we can see that y is also heading upwards, increasing towards positive infinity. There we go, y approaches positive infinity. Now the quartic functions, I'm sure you're seeing the pattern by now. So we have an exponent of 4, so these are fourth degree. All right. So again, we might not be as familiar with these. The positive one on the right comes down. It's going to look a lot like the second degree function without anything else on here. And of course, because of the negative, the reflection here, we're going to do sort of reflected version like that. Not my best, that one, but close enough for now. Okay, so the leading coefficient is -1 and 1 again. End behavior, as x is approaching negative infinity, what is y doing? And as x is approaching positive infinity, what are the y's doing? Well, going to the left towards negative infinity on the x-axis, you can see the y's decreasing to negative infinity, and they're doing the exact same thing on the right side as we head towards positive infinity on the x-axis. You can see the y's decreasing again. So both of these are going to have the y's approaching negative infinity. And last but not least on the right here, x approaching negative infinity, x approaching positive infinity. What is y doing? Well, it doesn't matter whether we go to the left or to the right, the y's are still doing the exact same thing. They're heading upwards in both cases towards positive infinity. So let's pop that in. Y approaches positive infinity. Beautiful. Those are the basics of end behavior. All right. End behavior. If we know the degree and the leading coefficient of a polynomial, then we can get a general idea of what the graph would look like. Okay, so basically we can predict end behavior and do a pretty simple sketch of the graph just based on the degree and the leading coefficient. So what we're really looking for is whether the degree of the polynomial is odd or even. And in the case of odd, of course, we're talking about are like x to the first power, x to the third power, x to the fifth power, etc., 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 all these odd powers. And on the right side over here, we'd have x with an exponent of 2, 4, 6, etc., all of those evens. Okay, so I'm going to pop the same thing down here, odd and even. We can do all the odds on the left and the evens on the right. Now, the other things that we need to look at, in addition to whether a graph has an odd or even degree, would be the leading coefficient. We have two possible cases, and that's the case of the leading coefficient being positive. Okay, we do positive on both of these top ones. Or the leading coefficient being negative, as we saw in our previous sketches. Okay, just from these two pieces of information, we can generally tell what the end behavior is going to be. So as an example here, I'm just going to choose the third degree for these odds, and I'm just going to choose the second degree for these evens. Okay, so for the third degree, positive, get a sketch that looks something like that. And if you had a negative coefficient, well, of course, that negative coefficient is going to cause a reflection, something like that. All right, we've generally seen these before. So just on this, we can get the end behavior as x is approaching negative infinity and positive infinity. What's y doing? Well, y is approaching negative infinity here, and you can see it's heading upwards towards positive infinity here. Okay, so just from knowing that we have an odd degree and a positive coefficient, we can already predict this end behavior. All right, so let's write it in for the odd and the negative coefficient down on the bottom here. So as x is approaching negative infinity, and as x is approaching positive infinity, little different this time. Heading off to the left, we can see y heading upwards towards positive infinity, and on the right side, it's heading downwards towards negative infinity. And again, just knowing these pieces of information, that it's an odd degree polynomial with a negative leading coefficient, we can already predict this end behavior here, okay? We can already predict that. All right, so what about if we have the even degrees? All right, so I'm going to pop in a quick sketch of a quadratic here. There we go. That would be a second degree. And a negative version down below. Okay, so on these even ones, you can tell automatically that whether we're going to the left or to the right on this graph, so it doesn't matter if we're heading towards negative or positive infinity on the x-axis, the y's are moving in the same direction, okay? So for the positive ones, you can see them both going upwards, and for the negative one, you can tell that both of our cases are heading in the same direction downwards. So for our end behavior, as x is approaching negative infinity and positive infinity, our y's are going to be doing the exact same thing, Okay, both of them are heading in the same direction towards positive infinity on this one. And the end behavior down here, both of these are going to be heading towards negative infinity because you can see it going downwards. Okay, so notice again on the right side that for these even ones with the even degree, you're going to get the y's moving in the same direction together. Whereas with the odd ones, you can definitely see the y's split in different directions. Okay, some key things to remember. Okay, so let's try this. Describe the end behavior of the graph of the polynomial functions. So in example 1, we're going to find the degree of this polynomial. That would be the highest power right there on the variable. So this is 4th degree, which is even. Then we're going to check the leading coefficient. You might think it's this -2 because it's right out in front of the polynomial. It feels like it's leading, but actually what is truly the leading coefficient is this 5 right here, okay? This 5 is the coefficient on the variable with the highest power, making it the leading coefficient. So our leading coefficient is, in this case, you can see it right here, it is positive. Okay, so if we have an even degree and we have a positive leading coefficient, we automatically know what our end behavior is going to be. Okay, let's try example 2 over here. A little more complex to tell what the degree of this polynomial is, because we actually have two sections, one on the left here. You see the parentheses. Okay, we have this over here and this over here, and they haven't been multiplied together yet. Okay, so you might see this 5th power and think this is a 5th degree polynomial. But actually, after this and this get multiplied together, x to the 5th times x to the 2nd are going to generate an x to the 7th. So this is actually an odd degree, and the leading coefficient, okay, we have this -8 here. Okay, it's going to get multiplied by this +2. Well, that's not going to change the fact that it is, in fact, negative. Okay, so if we have an odd polynomial with a negative leading coefficient, well, odd negative must be this right over here, okay? We can just take this end behavior and we can pop it in right over here. Make it better than that. Maybe my art skills aren't the best. All right, sliding down to increasing and decreasing. A function is said to be increasing across a certain domain where the slope is positive. And the function is said to be decreasing across a certain domain where the slope is negative. All right, so here, what we're going to do is just identify the sections on these graphs. You can tell it's the same graph, where we have a positive and where we have a negative slope. And that'll tell us where we are increasing and we are decreasing. Okay, so on the left, we want to look for where this is increasing. Increasing is anywhere that reading the graph from left to right. Okay, it's always important to think left to right, kind of like we're reading a book, we're reading these graphs. And we can see that coming in from the left, you can see how this graph is going up, 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 and it's going up, 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 and right until it hits this point, and then it sort of changes direction and it starts heading downward. Okay, that is not part of our increasing section once it's heading downward. But then right over here, you can tell it sort of changes again and it starts heading upward. So these are our two sections that are increasing. Okay, so we're going to write those sections, and there's two of them in interval notation. So on the left, this graph is heading off to negative infinity. And then heading off to the right, you can tell right here it's stopping. Of course, this would be at negative 2. So we're going to do negative infinity, comma, negative 2. All right, parentheses around those. Okay, then we actually have a second section off to the right, which of course starts at an x value of 1, and then it continues off in this direction. It just seems to be continuing to increase as we head to the right. So it's going to continue to increase infinitely. And let's pop some parentheses around those. Okay, so we want to be able to put these two interval notation pieces together. So all we have to do to connect them is just put in a union. So whenever we have two intervals we want to pop together, just pop a union in between them to show that they are together. Now on the right side here, we want to check where it's decreasing. Well, it appears to start here and it heads down this direction. It is decreasing from what looks like negative 2 to 1. So we're going to do an interval from negative 2 to 1. There we go. No union necessary because there's only one piece. All right, so let's talk about some important vocab before we move on. We're going to talk about minimums and maximums, both absolute and local. So an absolute minimum, the y-coordinate of the lowest point on the graph of a function. So I just want you to imagine that we have some sort of graph. Here, we'll do one of these. Okay, the lowest point on the graph would be the minimum. We've talked about these before. This would be right here. Now, we'd say this is the absolute minimum because there is no place on this graph that is ever going to be lower than that spot on the graph. So flipping it over for the maximum, this would just be the highest possible point on the graph. No point on this graph is ever going to be higher than that right there. So this is our absolute maximum. Now, a relative or local minimum and maximum is a little bit different here. So I'm going to use a slightly different sketch here. I'm going to put in a graph like this. Okay, so this I'll pop another one over here from the same example here. These show us both a local minimum and a local maximum. So a local minimum is a spot on the graph that appears to be a low point, kind of like a valley, right? Like a valley. Now, it's not the lowest possible point on the graph because you can see that this graph is going to continue downwards, but it is a valley, one particular spot where the graph is low. On the right side, a local maximum right here. Okay. It is a high point on the graph, but it's not necessarily the highest point because you can tell the graph is going to continue upwards. A lot of people consider this like a hill. Whenever you see a hill, a place where it goes up and comes back down, that's a pretty good indication that you have a local maximum. Of course, positive and negative. So a function is positive on an interval of the domain if the graph is above the x-axis, and negative if it's below the x-axis. So a quick sketch here. for each of these. So we'll put in, I don't know, another one of these. I like these graphs. Okay, so places where this graph is positive would be any place simply where the graph is above the x-axis. So this section here is above the x-axis, and this section here is above the x-axis, so that section is positive. So negative, I'll try to do pretty much the same sketch here. Beautiful. All right, so negative, this is just anywhere where it is below the x-axis. So these sections here, that is where the graph is below the x-axis. All right, let's see if we can put it all together and identify just about all this information on this guy right here. All right, so from the top, increasing and decreasing. So where is this graph increasing? Well, from the left, it's coming up and it stops increasing here. And then right over here, it starts increasing again. We have two chunks. We're going to need a union. So we have from negative infinity to, it looks like -2, union. And we're going to have 1 to positive infinity. All right, so where is this graph decreasing? Well, right here in the center. Okay, from -2 to 1, that's where the graph is decreasing. -2, 1. There we go. No union necessary because there's only one interval. The degree. Well, we can definitely tell that each of the ends are going in different directions here. So based on our information from before, we can at least tell that we have an odd degree polynomial. This one is actually third degree. And so we can automatically tell our end behavior if we have it sort of memorized from odd, even, positive, and negative. We can do as x approaches negative infinity and as x approaches positive infinity. Okay. Now this graph off to the right is definitely going upwards. So we can tell that it is in fact a positive graph. Or you can just read off the graph to get your end behavior. Heading positively and negatively, y approaching. Okay. Negative infinity to the left and positive infinity to the right. Okay, min, max. All right. So let's not get these sort of switched up. The relative maximum and the relative minimum, these are the hills and the valleys we just talked about. Okay. So where do we have a hill? Well, right over here, this appears to be a high point, right? Like there's a hill here. It's like a bump in the graph. We really only need how high the hill is, so the y value. So the relative max is at 6. The relative minimum, that would be this valley over here, right? This low point here. It is not the lowest point on the graph. We'll talk about those in just a second. And again, we really only need how high or low that is, so the y value here at 4. Now, maximum and minimum, again, this graph is continuing upwards and upwards and upwards, and it's continuing downwards and downwards and downwards. It's never actually going to stop increasing or decreasing. So we don't have one point on this graph that is the absolute highest or the absolute lowest. So we do not actually have an absolute maximum or minimum. So just pop in like none. None. Beautiful. Okay, so where is this graph positive and where is this graph negative? All right, well, let me get some of this stuff off of my graph so we can clear this up here. Beautiful. So where is the graph positive? Okay, positive. So that would be anywhere that the graph is actually above the x-axis. So this entire section here. And then where is the graph negative? Right over here. Unfortunately, we don't actually appear to have a point here to measure it by. But if we did, we could pop in an interval. We could make something up, I suppose. I don't know. -3, 0. Okay. Very nice. So let's pop a quick interval in. So from -3 and all the way off to the right, because it does appear that this is going to continue to be positive as it goes off towards positive infinity. So we'll go from -3 to infinity here. And coming in from the left here, this entire negative direction, it appears it's been negative all this time. So coming in from -infinity all the way until it reaches -3, it has been below that x-axis. Very nice. Okay, one more. So we've been through just about all of this. This would be a great opportunity for you to pause the video and see if you can fill these things in on your own. All right. Let's see what we can do. Where is this graph increasing? So it's going to be increasing from here to here, and definitely from here to here. Going from left to right, we can see the graph is increasing. So that would be from -2 to 3. And we have a second one, so we're going to need a union here. It would look like from 18 to infinity. All right, decreasing. We have two decreasing sections this time, coming in from the left all the way until we get to -2. And here, starting at 3, moving until we hit 18, so we are going to need a union again. Okay, so coming in from -infinity all the way until we reach -2. Pop a union in here. And then from 3 until we reach 18. Nice. Okay, degree. So we can tell the graph has end behavior that are both of the y and behaviors are heading in the same direction, so we know that this guy is even, has an even degree. Okay, so the end behavior as x approaches -infinity and as x approaches positive infinity, what is y doing? Okay, it's even, so both of the y's are going to be doing the same thing, and they both appear to be heading upwards to positive infinity, way up there. So I'm going to pop those in. Nice. Maximum. Once again, we don't actually have an absolute maximum here. What is that? Get that out of here. There's none, okay, because those arrows are indicating that the graph is continuing to rise. We do have a relative maximum, though. Relative maximum would be like a hill. So this would be a relative maximum. It is a high point on the graph, and that does appear to be at -6 on the y-axis. Minimum. We actually have both an absolute minimum and a relative minimum. So the absolute minimum would actually be this guy right here. Okay, so this valley is actually the lowest spot on the graph. The graph doesn't get any lower than this. It never will. And that appears to be at -20 on the y-axis. Okay, and our relative minimum, this is just another low spot, another valley, and that would be at -10. Okay, where is this graph positive? Where is the graph positive? Well, that would appear to be this chunk over here and this chunk over here. All right, so we're going to have to do an interval, two of them. So on the left side and on the right side, on the left side from -infinity, coming in until we hit this -5 right here. And on the right side, starting right here at what appears to be 22 and heading off till positive infinity. Where is the graph negative? Well, the graph appears to be negative between this spot and this spot. Like all this entire section down here, all of this is negative. It's all below the x-axis. All right, and that appears to start at -5, and it goes till 22. Lovely. All right, ladies and gents, I hope you enjoyed.